Today we are going to see new chapter, binomial theorem, sequences and series. Now binomial theorem has been deleted for this academic year by the revised syllabus. So 5.1 is completely deleted. So now we are going to see sequences and series. Sequences and series already you learnt in 10th standard. The same concept, the same sort of problems only you are going to see here. So the same arithmetic and geometric progression. In exercise 5.2 we are going to see sums 2 to 5. Write the first 6 terms of the sequences whose nth term an is given below. So an is equal to n if n is 1, 2 or 3. If it is greater than 3, you must use this one, okay, this particular part. So now first term. So since n is 1, we are using a1 is equal to 1. Since n is 2, a2 is 2. Since n is 3, a3 is 3. Now a4, that means n value is now greater than 3, so I have to use this here. So placing 4 minus 1 is a3, 4 minus 2 is a2, 4 minus 3 is a1. So a3 is already 3 and a2 is 2 and a1 is 1 substituted here. So the answer is 6. A similar way, a5 is a4 plus a3 plus a2, which is 6 plus 3 plus 2, which is 11. And a6 is a5 plus a4 plus a3, which is 11 plus 6 plus 3, which is 20. So the sequence is 1, 2, 3, 6, 11, 20. Such a way it goes on. And remaining subdivision you must do as homework. Write the nth term of the following sequences: 2, 2, 4, 4, 6, 6. Now I just separated odd terms and even terms. So first term a1 is 2 and a2 is 2. Second term a3 is 4, a4 is 4. And fifth term a6, a5 is 6 and a6 is 6. So now see here, these are all odd terms and these are all even terms. Okay. Now you see here, in odd term, see, this is 1. When you add plus 1, you will get 2. 3 plus 1, you will get 4. 5 plus 1, you will get 6. Okay. So in an, when the terms are odd, you have to use what? Here this value plus 1, you will get the answer. So here the value is n. So n plus 1, here you have to write it n plus 1. And here n value is directly given as the answer. 4 means 4, 2 means 2, 6 means 6. So here n, so here also n, only if the n is even. So odd term means n plus 1, even term means n. Now 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6, such a way it goes on. Now here I have written all the terms separating a1, a2, a3, a4, a5, right? Now you see here, in the numerator terms are just odd terms and denominator terms, numerator terms are the terms which you have the n value. Here 1 and here 1, here 2, here 2, here 3, so here also 3, 4 and 4, such a way 5 and 5. So n value is directly substituted, 1 and here 1. So this is n and here also this is n. Okay. Now see the second value, denominator value. So when you see the denominator value comes from adding 1 to the n value. So 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, 5 plus 1 is 6. So therefore here the answer is n plus 1 in the denominator, right? So an is equal to n by n plus 1. And next problem, 1 by 2, 1 by 3, 1 by 2, 3 by 4, 5 by 6, 7 by 8 and 9 by 10. So a1, a2, a3, a4 and a5 terms are written. Now you check now the numerator terms are just odd terms and denominator terms are even terms. You know how to represent an odd term. Odd term can be represented 2n minus 1. So substitute 1 here, 2n minus 1. So 2 minus 1 is 1. Suppose if n value is 2, 2 into 2, 4 minus 1 is 3. If n is 3 means 2 into 3, 6 minus 1 is 5. Such a way you can write the numerator, and denominators are even terms. So 2 into n is 2n. Subdivision 4, 6, 10, 4, 12, 2, 14, 0, 16, minus 2. Here also I have separated odd terms and even terms like A1, A3, A5 are 6, 4, 2 and A2, A4, A6 are 10, 12, 14. Such a way the remaining terms. Right? Now here you check, when I add the n value, 1 plus 6 you get 7, 3 plus 4 you get 7, 5 plus 2 you get 7. So 7 plus 0 you get 7. It means from the 7 if I subtract 1 you will get 6. So 7 minus this is 6, 7 minus 3 is 4, 7 minus 5 is 2, 7 minus 7 is 0. So finally here n, so 7 minus n. Now in the same way here, when I subtract, that means 10 minus 2 is 8, 12 minus 4 is 8, 14 minus 6 is 8, 16 minus 8 is 8. So here when I add 8 with this term, I will get 10. 8 plus 4 is 12, 8 plus 6 is 14, 8 plus 8 is 16. So here n I am having in this place. So with the n I am adding 8, so 8 plus n. The product of three increasing numbers in a GP is given. So you know how to take an increasing GP, isn't it? So A by R, A, AR. You already learned in 10th standard, right? Now the product of the three term is 5, 8, 3, 2. It is given. So A by R into A into AR is equal to 5, 8, 3, 2. So cancelling R from the denominator to the numerator, you will get A cube is equal to 5832, where 5832 is nothing but 18 cube, so A is equal to 18. Then secondly it is given, I just replaced A by 18, and secondly it is given when I add 6 to the second number. Okay, what is the second number? Second number is 18. When I add 6 it becomes 24. And when I add 9 to the third number, what is the third number? 18R. So 18R plus 9, it forms an AP. It is given in the question. So you know, in AP, second term minus first term is equal to third term minus second term, which is the common difference. So I have written 24 minus 18 by R, which is equal to 18R plus 9 minus 24. Now we have to, I just separated, bringing all the terms to, variable terms like R to the right hand side and remaining to the left hand side. So when I add, I'll get 39 is equal to, here taking LCM, 18 into R is 18R square plus 18 by R. Now bring the R to the left hand side, so it is 39R is equal to 18R square plus 18. Now rearranging, 18R square minus 39R plus 18 is equal to 0. Now you can divide by 3, so it becomes 6R square minus 13R plus 6 is equal to 0. So now we have to multiply 6 with 6, which is 36, and using the tree method I can write this as minus 9 minus 4. Divide by what? 6R, and divide by here also 6R. So cancelling that, I have got R minus 3 by 2, R minus 2 by 3, which is equal to 0, where R is equal to 3 by 2 minus 2 by 3. In the question it is given that increasing GP, so I have taken R is equal to 3 by 2 alone. If I take 2 by 3, the GP will be decreasing. So now replacing R by 3 by 2 in the first term, in the second term and third term, I have got 18 into 2 by 3, 18, 18 into 3 by 2. The answer is 12, 18, 27, which is actually an increasing GP. Last sum. Write the nth term of the sequence which is given, and you have to write the nth term as sum of two terms, a term minus another term. So first we will write the general term. So this is the first term, this is the second term, this is the third term, isn't it? Okay. Now how to write the general term? You see the numerator is 3, 5, 7, which is an odd term. So odd term can be written as either 2n minus 1 or 2n plus 1. Here I have to write 2n plus 1, then only I'll get 3. If not, I won't be getting 3, I'll get only 1. And the denominator you see n value square. Here also n value square, n value square. So it is n square. And the second term is n plus 1 the whole square. 1 plus 1 is 2 square. 2 plus 1 is 3 square. 3 plus 1 is 4 square. So the general term an is equal to 2n plus 1 divided by n square into n plus 1 the whole square. Now I have to write it into difference of two terms. So I see a n plus 1 in the denominator. So expanding n plus 1 is nothing but n square plus 2n plus 1. So I am adding a n square in the numerator and subtracting an n square. Adding n square and subtracting n square doesn't change any value. So here n square plus 2n plus 1 is nothing but n plus 1 the whole square and minus n square. Now I have to split it out, like splitting up into n plus 1 the whole square divided by the denominator minus n square divided by the denominator. Now cancelling n plus 1 the whole square in the numerator and in the denominator of the first term, and n square in the numerator and the denominator of the second term, I have got answer 1 by n square minus 1 by n plus 1 the whole square. And that's all. And subdivision which is in the second sum are left as homework. Thank you.